So this is the skill video for Unit 1, Skill 8 on absolute value inequalities. And even though I gave a full set of notes in class, I'm going to put two examples in this video so that you could listen to them and look over them as review, or if you had missed the notes in class. So we talked about how absolute value inequalities fall into two categories, either the and or the or, similar to compound inequalities. So let's look at one example here and we'll see which category it falls into. Let's start with 4 times the absolute value of 2x plus 3 and a minus 7 on the outside is less than or equal to 9. Notice we have the absolute value brackets and the inequality symbol, the less than or equal to, which makes this the absolute value inequality. Now the first thing that we want to do is isolate the absolute value. And this step is not new. We've done this before. So isolate the absolute value brackets. That will be done in 2 steps in this problem. First, we must add the 7. You have to get rid of the constant first. I rewrite as 4 times the 2x plus 3 is now less than or equal to 16. Then we divide by that 4, right? You get rid of that multiplier second. And we now have just the absolute value of 2x plus 3 is less than or equal to 4. 16 divided by 4 is 4. Now this is the step where we take a look at this symbol here. Okay? If our absolute value brackets are isolated and they are less than or equal to, that's fine, some number, then this is the and category. Okay? So what that means is that we could split this into 2 separate inequalities connected with the word and. So 2x plus 3, it could be less than or equal to 4, and 2x plus 3 needs to be greater than or equal to negative 4. See how I flipped the symbol and made the 4 negative? Both of those pieces were important there. Now, in class I talked about rewriting this as one piece, that repeated 2x plus 3, that we would write that in the middle, and you kind of trap it or create the boundaries of the 4 and negative 4. So on one side you keep it as 2x plus 3 is less than or equal to 4, and then you put the smaller boundary, the negative 4, on the other side. So this is how I'd like you to get used to writing your compound inequalities with the and connector. At this point, we just need to solve for x down the middle. So I need to subtract 3 from both sides. Remember, that means both of those outer sides. We end up with negative 7 is less than or equal to 2x, and 2x is less than or equal to 1. Okay, I'm going to just move that up a little bit. And then we divide by 2, and notice we will end up with some fractions, and that's fine. But now we have x by itself, 1/2. And this becomes our answer. Oops, bring that piece up. Now on a number line, we have our negative 7/2, which is the same as negative 3.5. And we have our 1/2, which is like positive 0.5. Okay? And we're saying here that x needs to be greater than or equal to the negative 3.5. So that means a closed circle and shading greater than. And x needs to be less than or equal to the 0.5, the 1/2. So a closed circle and less than. Notice those two intervals will overlap here in the middle, and that section is our final shading. So that is the graph that goes with these kind of and category absolute value inequalities. Okay, let's take a look at one more example, and this will be of the OR. Okay, so here's example 2. 6 minus 2 times the absolute value of 4x minus 1 is less than 4. So again, we start by isolating the absolute value, and we have 2 steps to do that again. This 6 is the multiplier, or excuse me, the 6 is the constant, the negative 2 is the multiplier. We always start by getting rid of the constant first. So we have to subtract. We're left with that negative 2 out front of the 4x minus 1 is now less than negative 2. Now we divide by that multiplier. Now notice that we're dividing by a negative, and that's really important because that's going to flip that symbol as we rewrite this. So the absolute value of 4x minus 1 is greater than positive 1, right? Negative 2 divided by negative 2 is positive 1. So that same rule applies. If you're dividing both sides by a negative, you still flip the inequality symbol. Now that our absolute value brackets are by themselves and there's nothing on the outside, we take a look at that symbol in the middle. Now it's a greater than sign. Okay? And a greater than sign means it's an OR graph. Okay? We'll see that the number line at the end definitely looks different. So we split this into 2 parts, but this time they're connected with the word OR. So 4x minus 1, it can be greater than 1, or the other scenario is that 4x minus 1 can be less than negative 1. Notice I flipped the symbol and made the 1 negative. Both of those happened at the same time. And now I solve. I'm going to start on the left here. I'm going to add 1 to both sides, and I get 4x is greater than 2. I'm going to divide by 4, and 2/4 is also equal to 1/2, so x is greater than 1/2, or, and then I solve the other side. When I add 1 to both sides here, I get 0, and when I divide by 4, I still get 0. So here's my answer, that x is greater than 1/2, or x is less than 0. Move all that up so we can get a number line on the bottom. Okay, now on the number line, 0 is the smaller of those 2 boundaries, and 1/2 is larger. X is greater than 1/2. That's an open circle and shading to the right. Or x is less than 0, so open circle and shading less than to the left, right? These are representing going to negative infinity and to positive infinity. But that would be the visual representation of all those x values that are the solutions. Notice that these 2 intervals do not overlap, but that's okay when it's an OR graph. And that concludes the review video on absolute value inequalities. There was one example. Example 1 was for the and then this example, example 2, was an example of the OR scenario.